48. Determine the molarity of each of the following solutions, and then we have letter F. So in this case, they gave us 0.000889 grams of glycine, which is C2H5NO2, and that's all in 1.05 mils or milliliters of solution. And we want to find out what molarity is. Molarity is, boom, it's equal to moles of solute divided by liters of solution. More simply, though, capital M for molarity, right? Capital M equals moles divided by liters. So that's what I'm going to write over here. The formula that we're going to use is capital M equals moles divided by liters. So if we're trying to solve for molarity, I need to know the moles that I have. It's just a unit of quantity. And I need to know the liters for the volume. Did they give us any of these? No. They gave us grams instead of moles. And they gave us milliliter instead of liter. So before we do this, we have to convert these two units into the units that we want. Doesn't matter which conversion we do first, but the first thing we have to do is we have to convert 0.000889 grams of glycine, which is C2H5NO2, and we have to convert that into moles of glycine, C2H5NO2. Fun fact, glycine is one of our amino acids that is necessary for our body to work. It's the only non-chiral amino acid for all you guys that are going to be taking organic chemistry. Ooh, so exciting. I love orgo. But let's keep going. So I have to convert the grams of glycine into moles of glycine. And then after I do that, right, I have to do step 2, right, which would be to take my 1.05 mils and convert it into liters. Now this kind of looks weird. I just noticed that, guys. So maybe instead of the dots here, I will put like the slashes for the steps. I think that looks better. Okay, so let's get down to it. How do we go from a gram of something to the moles of the same compound? That's this trick down here. If we don't want to use dimensional analysis, we can quickly just say that if we have grams, and in this case I labeled it as X, meaning anything, right? Here's the X down here. So if I have a gram of a compound or an element, and I want to find the moles of the same compound or element, I'm going this way. So all I have to do is just take that gram and divide it by the molecular weight, the MW, right? So all I would have to do here, is just take the 0.000889 grams and divide by the molecular weight. But the thing is that they didn't give us a molecular weight. So how are we going to find it? We use the periodic table. We've done tons of molecular weights before, right? We go on that periodic table and we see what the elements are and what their masses are on the periodic table, and then you just make sure that you have the total number, right? So let's do a molecular mass or a molecular weight of C2H5NO2. So you use your periodic table, I'm going to use mine. Let's see if we get roughly the same number. I'm going to do the exact values on the periodic table, but our answer should come out roughly the same. So I have 2 carbons, I have 5 hydrogens. Let's see, I got 1 nitrogen, and then I have 2 oxygens. Okay, so my number roughly comes out to being 75.07 grams per mole. That's the molecular weight. So all we have to do is take the grams that we have and divide it by the molecular weight that we just found out. So I'm going to take it and divide it by 75.07 grams per mole. That's the unit for a molecular mass or a molecular weight. Now look, the grams cancel, and you're just left with the unit of moles. That's why when you do this, you get moles. So let's just see what we got. 0.000889 divided by 75.07. If we're keeping up with sig figs, it should be roughly 3 sig figs, so 1.18 times 10 to the negative fifth moles of glycine, C2H5NO2. Okay, so we found out one component, right? We just found out the moles. So this number is going to go up here. So we just found out that this one was 1.18 times 10 to the negative fifth moles. Now we got to find the liters. And this is what we got to do, right? We got to take the 1.05 mils and convert it into liters. Well, here's the other quick trick, guys, right? Whenever we have mils and we want to go to liters, all we got to do is take the value that we have and divide it by 1,000. So I'm either going to take the 1.05 and divide by 1,000, or more simply, you can take the decimal that you have and move it over 3 spots to the left and fill in the zeros. Either way, you'll still get the same answer. So in this case, we have 0.00105 liters. And that's equivalent to 1.05 milliliters. Okay, now we have the bottom number, 0.00105 liters. Now all we got to do is just calculate. Maybe I'll put the calculation over here. So this would be like step 3. Molarity equals 1.18 times 10 to the negative fifth divided by the 0.00105. We get molarity equals, let's see, 1.18 times 10 to the negative fifth divided by 0.00105. Roughly 3 sig figs here, so 0.0112. And that's either in units of capital M is molarity, or since these units don't cancel, right? I can't cancel out a moles with a liter. They just stay. So it would just be mole over liter. And that's the answer. Woohoo! Okay, guys, what do you think? Hopefully this helped. This is all just coming down to conversions, and then plug it into the formula, okay? But I know you guys got this. Let me know in the comments. Thank you so much for tuning in. I really hope that this is helping you. Let's smash those quizzes. Let's smash those tests. Let's smash the homeworks. But more importantly, let's smash the subscribe button. So corny. But thank you. All right, you guys rock. Let's keep learning. This is awesome. See you in the next lesson. Bye-bye.